Test. That should be okay. And I'm sorry, but I suppose you can hear my sound, my voice just on one side, not the two sides. I didn't fix that. I hope it's going to be okay. So where were we? So many things happen fast. The basic, yeah, very big. Oh yeah, maybe I should just. Is it better? It should be a bit better. It should be a bit better. Test. I don't know how to balance it between the two sides. Oh, maybe doing that. I just put it in mono. So Nikolai, the music should be okay, great. And the music, if I wanted to make it louder, just let me know. Okay, great. Let's start. So I was saying the project is super simple. It's about creating a map of journals of science. That's it. The data is journals that we fetch from OpenAlex. Let me write that in the chat. OpenAlex. It's a free and open access source for information on scientific publications. So that's what we want to do. What we have done so far once per week in these streams is get the data, then comparing journals in order to create a network of journals. So we need to define why would two journals be connected. The choice we have made is to define a connection between two journals as the fact that at least one author, one scientist, would have published in the two journals. That's it. So we have done that, and the end result is a network of journals, and I'm going to show you that. There. So that's something I got from this morning. 70,000 journals spread out in a way that two journals, if they have many authors in common, they should be next to each other on the screen. So that's fresh from this morning, and the reason why it takes so long is that we have many problems to solve, like very pesky, to use Nikolai's word, pesky problems to solve, like how do you compare 70,000 journals, one with each others? And these kind of things can be quite computationally intensive. So we have to sort these problems out. But anyway, that's where we are. As you might wonder why we don't see, why do we see zero connections here? I just deleted the ages to make it quicker or to make it faster for Gephi to display the network. Because otherwise we have millions of ages, I think, and that makes everything super slow. So that's where we are. 70,000 journals. There is a kind of cycle, and there is a dense region in the center, and we have this kind of tail or protuberance there. The next step is to understand, is this picture just a kind of random result, or does it actually reflect something of substance about geography of science. So the only thing we need to do is to have the labels on the, yes, yes, I agree, Arabian hood. Yeah, I agree. It's like super, like we are super curious about it, right? Maybe you could guess that maybe we have interdisciplinary journals there, and we would have the different scientific fields being in a continuum all around it. But it's also very possible that it's just a bad visualization, and that actually it's just a huge mistake because of the way we mishandled the data. So the only way to understand that is to see the journal names. So what do we have as a data? I switch to the data laboratory. So as you see, the operations are super slow, and we have just, yeah, that's what I expected. So we have just node IDs. What are these IDs? They are arbitrary numbers, really. So let me tell you, I'm taking that from the other side. We have IDs for each journal that have been defined by OpenAlex, you know, the provider of the data. So these IDs start with a letter. I think it's W for work. No, not W. S, sorry. S for source. You know, a journal is a source, right? So the IDs for journals start with an S in OpenAlex, and then you have a string of numbers. So S, 3, 5, 4, whatever. And conveniently, OpenAlex has, I mean, before this ID, S something, you can just prepend it, to use a fancy term. You can prepend this ID with a URL, https api.openalex.something. And when you take all of that, you know, HTTPS, whatever, until the ID, it's actually an address that you can paste in your browser, and it will just display the full information on the journal. So that's the IDs. So why don't we have that here, right? The reason is that to speed up computations, of course, we will not keep all the HTTPS stuff. So I removed the HTTPS prefix of the ID. And then we were like with S something. So I removed the S because it's always S. So, and then we had a very long, like, long series of numbers. And this is where I did a final mapping or adaptation. I removed this very long series of random numbers for what you see there. And why? Because it's still numbers here. Actually, these are shorter numbers. And believe me or not, that made a big difference in the computations we had to make, you know, to compare journals. So now we have to trace back our steps to go from these short numbers that you see here to the original ID of the journal. So maybe you were here in this Twitch stream to see, you know, fancy, not visualizations, but fancy exploration of the map. And maybe we will get there in the hour, but we have to start with borrowing data, wrangling from these IDs that you see on screen to the original IDs that are OpenAlex IDs. So that's what I'm doing now. You know, again, the principle is that I do things live with you on this Twitch. I don't just provide the end results. So what do we need to do? I would like to do it fast so that we can basically. Oh, I think we can. Yes. Okay. I should put a timer. I hope I can do that in less than 20 minutes if I start now. Because let me show you. We have files actually. We have everything which is almost ready for that. If you look at data, we have a journal. Do you see that? No, maybe a bit. I have a file here that maps journal IDs to so this in this file, and I can open it for you. It's not very complicated, right? Do you see it? No. Do you see it here? Yeah, sorry, I have kind of a fancy double. You see two screens here. It's not really. Let me fix that. Yeah. Oops. Yeah. So we have this file, on the right, after the comma, you see the ID that we have in Gephi, and before the comma, on the left, you have the OpenAlex ID for the journal. So I just have to then add an S before and the HTTPS whatever, and that will give us the entire information on the journal. And by the way, we just need the title, right? Later we can do fancy stuff, but we just want the title. And once we have the title, I can import it in Gephi as a label. Yes, that's what we need to do. So let's do that. I'm gonna create so I'm gonna call that hydrating journals. Hydrating journals. Why hydrating? It's a fancy term just to say that when you have like an object which is represented by a very dry ID, you hydrate it, so you enrich it with attributes, in this case the journal name. So I first need to open the file, so read string, or read lines maybe, read all lines, yeah, that's better. Read all lines from the file. Let's not do that too quickly. I'm gonna just need to, so it looks like a little dense, I'm just hydrating journals. I'm just repeating. Oh, I hate this keyboard issue. Oh, yeah. So what we want to do is add journal names to a GEXF file, right? That's exactly what we want to do. So first we need to open the GXF, load the GXF file. So GXF is, the file format for Gephi. I just happen to have that conveniently there. This is the thing I've written this week to remove this morning actually, to remove the ages. So it's just exactly all of that, graph model, and then export it. So that's exactly what we need. So copy, paste, paste where, paste there. Oh, Gephi is not a dependency. I have to add it here. Where is Gephi? There. I should. I'm gonna copy most of it. Do I? No, just the Gephi dependency. The Gephi toolkit is a way for, to use Gephi, but not through a graphical user interface, but just through a programming interface, like I am doing now. Oh, there is no version, so let's take it there. So now we should be able to import all of that. So what I've just copy-pasted in the code here, if it just wants to, we're gonna do GXF path. What I've just pasted here is the code that opens a GXF file and exports it. What it does is remove edges, but I'm removing that. I don't want to do that. Why is it? Oh yes, I need to download. Oh, and by the way, the connection is not great. Let me see if I can just shift to the Ethernet cable. Yeah, the connection should be much better now. I was on Wi-Fi instead of cable. Okay, now Gephi, the Gephi dependency is imported, so I can just, what I'm doing here is adding the import statements in my code. You have that in many, if not most. No, not that container, I made a mistake. This one. Okay, so nothing really important here, just mindlessly adding the import statements that my coding environment is suggesting. Okay, so with this bit of code, I can import this file here in my program. So now what do I want to do with that? I want to add as a label to each node the journal name. So as I said, first I need first to open this file that you see here. So can I just copy the path? Is there something like copy to clipboard, copy full file path? Great. So I want to read the lines from this file. Done. Why does it complain? Oh, because it's a path. Okay, not. Okay, done. So where do the lines go once they are read? Well, I'm going to add a. So it's like a journal IDs mapped. Now I want to put that in a map. So map string from a string to a string. So journal. So I'm going to call that open Alex ID to integer ID. It's really long, but at least later I'm going to remember what it does. And then for each line, I want to, oh, by the way, I want to do something else. I want to map the integer IDs to the open Alex IDs, integer ID to open Alex ID. Yeah, so I should split on the comma. So I'm mapping from the integer ID to the open Alex ID. Why is it complaining again? Just curious here. Let's see. Oh yes, of course, I didn't declare the array as I should have. Okay, done. And when you think of it, we're almost there. So the question is, do I make calls to the open ID, to the open Alex? Let's have a look together. So this is, as I told you, this is an open Alex journal ID. If we go to our browser, and it's opening very slowly on my computer. So slow. So we have the complete api.openalex.org source. Yeah, just remember by heart now. And then S, and then the this string here is just the string I copied there. The first in the file. So and then when I click enter, OpenAlex returns a full description of the journal, and what we want is the display name. In this case, it's French, repère cahier de danse. We have alternative titles, but we don't really care. So what I would like is to do a call to OpenAlex. Yeah, I suppose. It's just, it involves very small JSON manipulation, but in Java it's always a bit boring. So let's do that nonetheless. Okay, so back to, we are reading this GXF file. This thing here, graph model, is what gives you access to the nodes and the ages and the attributes. So we do graph model get graph. Get nodes, I suppose. And now I think we say to array, because it's a way to, I don't know. Otherwise, we're going to have a concurrent exception. Anyway, to array, and we get an array of nodes. And then we iterate through nodes. And for each node, we're going to fetch its title. And this is where we have to, I hate it. I love Java, but in this case, I have to do, a call to, I have to make a call to OpenAlex in a way that is going to take me 2 minutes. So I'm going to prepare the call here. Well, I'm going to put that in the loop. So no filter. So you see what I do here? I'm going to take the node ID, ID, which is an object, but in this case we're going to cast it, as they say, as a string. So for each node we call the API for its, to retrieve its JSON stuff. So that's the URL. We have not made the call yet. The call is being done there. And then we retrieve. I'm just pasting that from earlier code. So we do a call. I suppose it's highly inefficient. Let's do, what I'm going to do is, object declarations, I'm going to keep them outside of the loop so that the same object is reused. It should speed up things. Oh, the client especially, the client should stay outside the loop completely. And the response, same, should be declared outside of the loop. Oops. Almost there. And then what do we receive? We receive a JSON file, and from the JSON file we get the journal's name. In practice, we're going to receive, so we want the ISSN, which is what, oops, that's ugly. Oh no, that's not. Oh yeah, no, it's not ISSN at all. It's like I just fetched the display name. It's like nothing more simple. Display name, okay. So get, it's like, yeah, get a string. Display name, that's it. That's the name of the journal name. And we add this journal name as a label to the node, and we're good. So it's quite easy, at least on paper, right? Node set label journal name. Otherwise, say there is an error when retrieve name of journal. And then we export it as a file where we call it journal map with names. Okay, that's it, done. So we have the thing here. Why does it say that? I almost made a mistake. Thanks, NetBeans, for the hint. I forgot to map the ID to, where is that? It's here. Ooh, big mistake. as I told you, the ID of the node is not the OpenAlex ID. It's just an arbitrary ID. So I first have to retrieve the OpenAlex ID from the map I have created above. So OpenAlex ID, yeah, that's better. And that's the thing we're going to write there. And here we should cast it as a string. Why is it complaining again? Oh, because the parenthesis is not closed, yeah. All good, right? We're gonna open our map, our Gephi map. We load, and then we retrieve for each node ID the name of the journal, and we set it as a label to the node, and then we close it. Let's hope for the best, launching that. So we have, 70,000 journals. Oh, that's going to be 70,000 calls. That's not good. Shit. That's not good. That's not good. That's not good. I didn't think of that. Too many journals. I mean, we can do that, but we can make 10 calls per second. So it's going to take 7,000 seconds, which is 2 hours. Hi, Veronica. Well, you arrive at an interesting time. I was about to launch the retrieval of the journal names. Let me show you. Veronica, so we have this beautiful map. We don't know whether whether this map of journals makes sense or not. In order to see that, we should add the names of the journals as the labels to the nodes. And when you arrived, I had just finished writing the code for it. But then launching it, I realized that we have 70,000 journals. So it's going to take ages, literally 2 hours. But we can make several. And Nikolai very reasonably says we should just calm down and take a sample, but I hate being reasonable. So I think OpenAlex has a feature where you can retrieve many IDs at once, right? So we're going to just do that. Like you send a batch of IDs and it returns back. Like you see here, get list of entities, lists. And I think we can retrieve 200 at once. So it's 200 faster, 200 times faster. Yeah, but how do you? Yes, I think I remember that. So filter, it's kind of cumbersome, but it works. Now, Nikolai, it's gonna be okay. It's just I have to be patient and write some code. Yeah, where is that? I think it's, yeah, that's all. You can combine 50 values. is that? OpenAlex, yeah. Yeah, it's the okay. Let's be a bit more rigorous here, because what I do is, you know, I am looping through. I mean, I'm doing two things at once. So no, yeah, I could do that, but I have a dump of the works, not the journals. So it's okay, I'm gonna do, you know, I'm gonna take the map of the things I have here, and I'm gonna do the looping here. So let me say that in a better way. So I have all the journal IDs, right? So for map entry string, so for each journal ID, it's gonna work. It's gonna work. Don't worry. Oh yeah, of course. So this is an OpenAlex ID. So we can send batches of 50 IDs. Can we start at 1? I need a string builder to write the. So we're going to send a query where we say, send us the journals names for OpenAlex ID that, or that, or that, or that 50 times. And then we send these 50 requests at once. These 50 questions in a single request. So it speeds up by 50. I just have to write it, right? So that's what I'm doing now. And we do. I just have to see an example of. Can't they show us an example of that? Come on, honestly. Yeah, I think it's there, or. Oh, that's the pipe symbol, very simple. Yeah, very sensible. So this OpenID append pipe symbol to say or. Oops. And we have to stop when we get to 50, right? If count IDs equals 50, then we're gonna open a new and then we could do that. Then I'm gonna open a method just by itself, void call OpenAlex. So the heaviest object is the client. I shouldn't. Well, I'm gonna do put all of that there. Okay, as global variables. So if we are at 50, call OpenAlex with this strings, with these IDs, and then start over. Yeah, before that we want to remove the last append, or we do. Okay, pretty good. So calling the thing, ooh, everything is it. That's not important, but that has moved. Well, my file is completely. So how do we do the filter again? Works filter equals. Okay, filter equals. I just want to make sure this is OpenAlex. Okay, OpenAlex. Okay, so with that, we should retrieve. Why is it complaining? It wants, yeah, exactly nothing. Complaining again. So if the response is okay, get the JSON, and then for all of the 50 objects, so that's what we want to change. We're gonna just create a map. We're going to hold the values of the names of the journals in a temporary field. I'm going to put all of that as global variable names, because otherwise so it's not really clean, but it's faster. So as you see, I create a temporary data structures where they're gonna help me later, where I'm just storing how arbitrary IDs map to OpenLX IDs, but also the reverse, how OpenLX IDs map to these arbitrary IDs, because we're gonna need that later. So we're gonna receive, I suppose, an array of works, not just not works, by the way, sources. So let's do a test. Sources. Yeah, we need to test it for sure. Filter OpenLX to the OpenLX ID, and we want 2 IDs. Let's pick them from here. So cahier recherche dense, I think it was this one. Oops, where was I? So this one, by the way, it's with an S, or this one here. Oh, I hope it's not the full ID. Oh, I guess it's the full ID. Shoot. Oh, shoot. As I told you at the beginning, the full ID is actually longer. It's like, it's OpenLX / I think it's that. You know, with the whole URL at the beginning of the, I think it's that. We'll see. We are here to test anyway. Okay, I'm testing, retrieving 2 journals. It works. So repère cahier de danse, okay, and the second one is HSOA, Journal of Psychiatry, Depression and Anxiety. Charming. And this is an array, right? Oh, we have a meta and then results, which I suppose is, so meta, count, whatever, and then results, it's an array. Okay, fine. So we should get to results. Okay. So get array. Why don't JSON array, get JSON array results. JSON array, okay. And for each of these results, so how can we iterate? Oh. Oh, JSON values. I hate JSON values because you have to. I had iterated on arrays, maybe here. So I'm shifting files. I'm just trying to find a place where I have iterated on arrays. Yeah, there. So I'm gonna use the same syntax. Okay, just and we just add to the so we need a last map, which was yeah, so we could do that integer ID to journal name. Can I do that? Yes, I think so. So let's look, how does it look? So we have the result and we have the display name, right? Yeah, very logically. Get string. And once we have the journal name, we can ooh la 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 la. So much, so many boring. Oh, we have the ID right there. Okay. I think I had a method. Again, let's reuse the method I had here. Not sanitize. No, I thought I had a method to. Where is the method? Maybe here. Yeah, probably here. No. Oh, I'm gonna have to write it again. It takes 2 seconds, but maybe this one. Yeah, as you see, I'm the most lazy person on earth. Just want to just put it at the end. Keep last part of the ID. Private static. I'm going to just fix this file, which is completely broken because I must have missed a parenthesis somewhere. Oh, I can't keep it like that. Why is it? Oh yeah, because there is no work on GeoXF. Okay, things should be cleaner now. Yeah. Yeah, the editor has kind of broken the presentation, but it's quite easy to recover. Look at that. Whew. Oh, come on. Almost there. Good. So back to where we were. So it's the open Alex ID. Fine. And this is what we want to store. Look in this thing. Where was integer? Okay, no, so first we have to do that. we want to retrieve the integer, get integer ID, and that's what we want to store there, integer to journal name. Put integer ID to journal name. Whew. And now we can loop on the nodes. So let's do a quick calculus. How long is it going to take? 70,000 journals divided by 50 divided by 60 seconds. 23 minutes, that's super long. So be it. 23 minutes. And it's 4. Well, I'm going to run it after the stream, but I'm going to launch it in the stream. And at least we're good. So this thing retrieves. Okay. Okay. So this is not add journal names. This is get journal names. Get journal names. And once we have the journal names, we can add the journal names. Look at that, how easy that is. Yeah, good. That's it, I suppose. Then the thing is exported. So I just have to add journal names to. So we just need, where is the file? Where is the file? The file is there, right? Edge removed, yeah, this one. Good. I should also introduce a pause in the calls, because you can do just 10 oh, no, it's not 23 minutes. I can do 10 calls per second. It's going to be less than 5 minutes, actually. Great. I just have to introduce a pause here. Thread sleep for 100 milliseconds. Yeah, good. So it should take like, hopefully, 2 minutes or 3 minutes. Why does it complain? Man, what's the issue here? Cannot find symbol. It's right there. GXF path. Why? Okay, good. So I'm just compiling it just for as a kind of a superstition. Yeah, I should really also store the journal names in a file so that I don't have to do that all over again. Almost there. It's just, yeah, me too. I'm super curious. Okay, go. It's gonna do an error, right? First time I launch, but go. Let me show you here. Okay, so launching the retrieval of the names. Attempt 1. Stop. Just a mistake everywhere. Error. What's the deal? So I must have made a mistake in the... Let's print the URL. The URL must be wrong or something. Come on. Come on. Okay, so the call is made to HTTPS, API, OpenX, not all sources, filter. Oh, okay, it's not the proper... Hey, why that? Interesting. The pipe gets turned into a percentage sign. Is it the joke, all right? Is it about escaping the thing? Let's Google that. URL pipe gets turned in percentage sign. Oh, I should. Yeah, I should. No, but I should escape the pipe. Okay, it's that. It's. I suppose. But it's a pity that it doesn't do it for me. I'm a bit surprised it doesn't do it for me. Strange. Oh, 7, 7. Oh, it does actually. No, it has done it for me. No, so it's not a mistake. The thing is correct. The pipe has been escaped with the percentage sign as 7. I did not forget to put that, right? Or did I? Oh, I forgot to put that, I think. No, it's just that. Yeah, you see, I just forgot to do that. Look at that, it's my mistake. It's here. It's there. It's not, you can't put the row ID, you have to put that in front. I have discussed that on the stream just before, but I forgot. So what's the proper OpenAlex dot? No, I'm doing copy. Just copy that. Yeah, that's it. Okay, new try. Why does it complain? Yeah, I could do things properly. Yeah, I think it's correct. Fetching the journal names second. Please, error, okay. Okay, so what we need to do now is write the error, because OpenAlex provides very explicit error names. So let's do that. Maybe I'm sending 51, off by 1 error, maybe. We'll see. Okay, error, and the error is, ladies and gentlemen, not found. Okay, so my mistake in the... Oh yes, there is... No. HTTPS api.openalex.org. api.openalex.org. Sources. Yeah. Filter. Oh, but it's not the path, right? Yeah, okay, got it. Okay, it's not the path, these are parameters. So it's with query, actually. Okay. the query is that, and now we should, we never know, right? But I think it's good now. Fetching journal names, third. Oh, I forgot. I'm fed up with forgetting stuff. I forgot to add the S here. Damn it. Okay. We are at the fourth attempt, right? Fetching journal names with OpenAlex, fourth. It works. So I just left the print of the URI, so that's what you see on screen. But these are not error messages; they are just, you know, the silly me who left this. Where is that? You know, this print of the URI, but no error. So this is big. Well, so Nicola is here, but. If others are here, we might see in a couple of minutes all the journal names, and maybe I can then, while it's happening, let me show you that Veronica was there actually when I started streaming on Twitch. I started last October, and the first project I did before this one is to create a plugin for Gephi, and you see it here. I did that in a completely different context. I just wanted to start coding live, and I didn't know what to do, and actually Veronica suggested this idea for a plugin, which I think is really nice and powerful. It allows you to do some text exploration on a network. But I did that, and but what I mean is that we have a use case today with the labels. We're going to be able to explore the labels not one by one, but with this plugin we should hopefully see you know, like for a region. Let me show you actually. Yeah, you see that this is a selection region. Let me do a couple of things. First I'm gonna, and I would like I would like to see better oh, nice. So the plugin will help us when I'm just hovering a region, as you see here, is gonna display there on this panel the top words of the journal names. So if we have a lot of journals in biology, I expected to see biology and neuroscience and stuff. Of course, we're going to see journal and review first, because these top words are not going to be removed. But this plugin should help us investigate the. Okay, still running. So all of that is just you know, it's an expectation, it's a hope, but things seem to be running. I hope we won't have memory issues. Maybe I should be careful with that. Yeah, I don't want to have an out of memory issue. I'm streaming, I have Gephi opened. Oh, there is a risk. 70,000 strings, not big, but could be enough to crash the memory. Let's keep our fingers crossed. Yeah, I'm not sure. I'm not sure the plugin for a map of science is the most. I'm still not sure what's the. I suppose we have many use cases for maps, but I didn't think of a Gephi plugin as the most obvious one. So what I have in mind with maps is I don't know exactly. The ability for any bibliometrician to create their own maps with parameters on the time span, like create a map of science based on the data from the last 2 years, and then based on the data from 2 years before and 2 years even before that, as a way to yeah. So chronological snapshots, but geographical snapshots, for a given country. So a map of science of Romania or France or of a city, just a city. Maps of science based on discipline, just the map of science of economics. So in terms of ergonomics, I would see that as a command line interface, maybe, where somebody would input their parameters, geography, time span, subfields, and then the map would be created, and the output would be PNG files, but also GEXF files. And why, Nikolai? What would be the dark side of it? An AKM to some dwarfs, you have to explain that to me. So just on the map, so a kind of command line interface or using no-code functions, you know, the website I'm developing as a way to create those maps. So that's one big use case already, but I suppose the end users would be bibliometricians, mostly. People who have an interest in... Yeah. Yes, that's possible, yes, indeed. And the other use case would be overlays. Again, an idea I'm taking from the work from Ismail Rafols and Lut Leijersdorf and Alan Porter. So overlays, in the use case is quite different. The map is provided, and the end user is asking to overlay some information on these maps, like their publications, or the publications of a university, or the publication of a list of papers. For example, where is sociology being discussed in economics? You know, so you take a list of papers that mention sociology concepts, and you overlay that on the map of economics. So that would be yeah, Nikolai, well, it's super, you're right. I mean, it's as you say, double-edged sword. That was a good way to put it. It's like, I agree, it would lend itself to being used as a tool for monitoring and measurement and evaluation and control, ultimately. But that's one possible use. The other use is just exploration. You know, what are people doing through space, through fields, through time? I'm a bit more interested in this exploration type. Look at that, we're almost done. Okay, let's see. This is really like opening the oven and getting the cake out. Where are we? We were in Maps of Science, I think. Ta-da, 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 ta-da. Do you see what I see? No, you don't see clearly here. Do you see that? Okay, so I'm going to close this one just to save. Okay, and I'm going to open the one we have just created here. So by the way, it's undirected. Sometimes I forget to change here. By default, it's considering it as directed. Yeah, drum rolls happen to existing up. So that should be the same network as we've seen before. You know, exactly the same, except that if we go to Data Lab, oh shit, we don't have labels. I'm dying. Oh, oh no. Well, I guess I know what I did. No, I'm not exactly sure. That's strange. What I did, I suppose, is I don't know actually. I'm not sure. And this, I think, this exposes the big weakness I have in terms of computer science fundamentals. I thought that when you were modifying nodes there, the underlying collection of nodes was modified as well. It seems not. It seems that the two array creates a kind of, copy, which is not, and the changes you make to the nodes in the copy do not affect the underlying nodes in the graph. So basically, any change that you make here are not, there's a term for that. These changes are not translated in the original collection. I think I am very good at teasing, and keeping the suspense for a long time. Oh, what a pain. The good news, so to speak, is that now we know how to do things. I'm sorry, I'm going to have to run it sometime this week before the stream of next week. So when we're going to join next week, by the way, yeah, next week, we're going to be already at the next step because I will have run this thing properly by then. So let me do a bit of promotion. If you want to have some news between now and next week, do follow me on Twitter. In any case, if you are on this stream, I suppose you got the news from Twitter. But if you didn't, for some reason, I mean, this is where, if you want to see me, oh, I forgot the, if you want to see me sharing the results, yeah, it's really bad teasing, right? Yeah, I'm going to share it on Twitter, but more seriously, I would really love to engage in a conversation about these results well before next Wednesday. And then when we're going to have that, what are we going to do next Wednesday? I'm not sure. It really depends whether we have a good news or bad news. If it's good news, like the map is actually consistent, well, it's really great if we have that. If we have a good map, we have two possibilities. Either we go further trying to, to do more, but maybe the other possibility would be to stop and consolidate what we have done so far, and especially consolidating in the direction of releasing the thing. I think I think it's super important to because it's going to be a kind of academic output as a paper, this thing for sure. But it's the second thing is that we also I want to put that in the hand of the users, the bibliometricians, but also the academics and anyone who is interested in the dynamics of knowledge. And to do that, I should stop exploring methods and I should just go in the dirty business of creating a command line interface. Yeah, I don't know what you're talking about, but I'm gonna check that right after the stream. So yeah, depending on the results, I think the most productive thing we should do next week is stop and consolidate things to release it to the users, you know, filtering the automating the creation of maps based on a series of parameters. Yes. Okay, well, thanks to you both, Nikolai and Veronica, and sorry for the funny ending, but see you soon on Twitter with actual results. Okay, have a good rest of your day. Thanks again for being there, and see you very soon. Cheers.